Beds in a hospital occur randomly at an average rate of 1.8 beds per hour. In this video, I'm going to find the probability of observing 4 beds in a given hour, B, more than 2 beds in a given hour, and lastly, I'll look at observing at least 2 beds in 3 hours. So that's the information that we are given there. The probability of an event happening a certain number of times within a given interval of time is modeled by the Poisson distribution. So in this case, we are looking at the number of beds per hour. So the number of beds per hour there is modeled by the Poisson distribution. If the average number of beds per hour is lambda, then the probability that there will be x beds per hour is probability that x is equals to x is exponent of minus lambda multiplied by lambda to the power x divided by x factorial. That's the Poisson distribution there. In this case, we are given that our rate is 1.8 beds per hour. So I can write down that our lambda there is 1.8. So now moving on to the first part, we are looking at the probability of observing 4 beds in a given hour. 4 beds in a given hour, we are saying that is the probability that x is equals to 4. So in our formula here, we substitute x equals to 4 and the value of this lambda here. So we have exponent of minus 1.8 multiplied by 1.8 to the power 4 divided by 4 factorial. And this will be approximately equals to 0.0723. So the probability of observing 4 beds in a given hour is 0.0723. So that's for the first question. I now move on to the second one. More than 2 beds in a given hour. More than 2 beds in a given hour, that's the probability that x is greater than 2. Probability that x is greater than 2. Let me just draw the number line so that we have those discrete values there, 0, 1, 2 up to infinity. X greater than 2, we are saying values that are greater than 2. Values that are greater than 2 are these ones. There are many of them. So to calculate the probability that x greater than 2, if we're looking at these discrete probabilities, it might be difficult to list all those probabilities because they are infinitely many. So we can use the property that probabilities add to 1. So these probabilities, the one greater than 2, if we add them to the probabilities for x less than or equals to 2, the ones that I've highlighted on top there, they will give us a 1 if we add those 2 probabilities. So the probability that x is greater than 2 will be equals to 1 minus the probability that x is less than or equal to 2. X less than or equals to 2, we are saying x 0, 1, or 2. So we would have that the probability that x is greater than 2 is 1 minus the probability that x is equals to 0 plus the probability that x equals to 1 plus the probability that x is equals to 2. So for the probability that x equals to 0, we substitute x equals to 0 here. For x equals to 1, we substitute x equals to 1 there. For x equals to 2, we substitute x equals to 2 there using this lambda here, the 1.8. So our probability becomes 1 minus exponent of minus 1.8 times 1.8 to the power 0 divided by 0 factorial plus exponent of minus 1.8 times 1.8 to the power 1 divided by 1 factorial plus exponent of minus 1.8 times 1.8 squared divided by 2 factorial. And those values will simplify to 1 minus 0.1653 plus 0.2975 plus 0.2678. And that will give us a value which is approximately 0.2694. So what you are having there, the probability of having more than 2 beds in a given hour is approximately 0.2694. I now move on to the last one there, the probability of observing at least 2 beds in 3 hours. 2 beds in 3 hours, our rate now is now changing. Both for the other ones, we were using a rate which is per hour. So we would need to recalculate our lambda. If the average rate per hour is 1.8, Then for 3 hours, we would have to multiply by 3. So we would have our lambda now will be 1.8 times 3, which gives us a 5.4. So for part C, we are using a rate of 5.4. 5.4 per 3 hours. And what we want to calculate there is probability of at least 2 bets. At least 2 bets, that means x is greater than or equal to 2. Probability that x is greater than or equals to 2 is equals to 1 minus probability that x is less than 2. So we now go on and calculate those probabilities, and it will give us 1 minus the probability that x equals to 0 plus the probability that x is equals to 1. For the probability that x equals to 0, we substitute x equals to 0 here using this lambda. For the probability that x equals to 1, substitute x equals to 1 here using this lambda. And we have 1 minus exponent of minus 5.4 times 5.4 to the power 0 divided by 0 factorial plus exponent of minus 5.4 times 5.4 to the power 1 divided by 1 factorial. And that will simplify to 1 minus 0.0045 plus 0.0244, which will give us approximately 0.9711. The probability of at least 2 bets in 3 hours is 0.9711.